Hello everyone, my name is Muhammad Reza Everly and I would like to present our work in ICCP 23 called Unified Out-of Distribution Detection, a Model-Specific Perspective. So first, I would like to talk a little bit about OD detection. So in traditional machine learning problem, would usually assume that the testing data has similar distribution to training data, but that is often not the case in real-world problems, so the goal of OD detection is to detect such examples. So if we consider a certain classifier and a data point from a certain distribution, the goal is want to design a scoring function that outputs a higher value for ID data and a lower value for OD data. And we want to accept them only if it's higher than a certain threshold. So there are many types of OOD, but they can actually be categorized into two major groups, which are covariate shift with different domain and semantic shift with different classes than in distribution data. So for semantic shift OD detection, the goal is we want to detect those examples, and this has been the main work in OD detection, and there has been many works in this problem. For covariate shift detection, on the other hand, it has not been truly explored, and the reason is because they are fundamentally different than semantic shift detection. For semantic shift data, the model cannot classify them, so that's why it should always be flagged or detected. For covariate shift data, on the other hand, the model can classify them, and so there's a question of whether we should accept or reject them. So there are two main works in covariative detections. The first one is to accept covariative data, but what if the model is weak or cannot classify well? And in that case, the second option is we can reject covariative data, but then there's a question of what if the model is robust or can classify the data well. So these two actually make a specific assumption on the model. The first one assume that the model is robust, and the second one assume that the model is weak. So that's why it should be rejected. So our goal is we want to bridge these two previous frameworks. And so the goal of our framework is we want to accept the correctly classified data and reject the misclassified data. So we can see that our framework essentially unifies all the existing frameworks. And also we can also see that previous frameworks, they either impose an assumption either on the distribution shift or the model itself. So in our framework, the goal is we want to accept the correctly classified ID and covariative data, and we want to detect or reject the misclassified and mis the misclassified ID and COD data and all of the semantic shift data. For evaluation, we consider three main metrics. For semantic shift and ID data, we consider the false positive rate. And for comparative data, we consider using F-score because we want to evaluate how well the model can accept the comparative data and how well the model can reject the misclassified ones. So for the first scenario, assuming that the data only comes from distribution, we perform experiments in that scenario, and we see that the performance improves when the ID accuracy is higher, and we can also see that the best methods is MSP, and there are also some exceptions which are using red norm and the model robust ResNet. For comparative data, we want to see how well the model rejects misclassified COOD data and accept the correctly classified COOD data. And we can also see that the performance improves when the accuracy on COOD data is high and MSP performs the best in all of the data sets. And lastly, we also want to see how well the model performs for rejecting semantic shift data in our framework. And we can also see that the performance improves when the ID accuracy is higher with some exceptions. So we want to conclude that for OD detection, there are three main ingredients to consider. The first one is the model, the second one is the sources of OD, and also the scoring function. And there are no best methods that work in all of the scenarios, but we can also see that MSP performs the best in ID and COD cases, and MSP performs favorably in semantic shift in our framework. And we would like to thank you for you who have watched this video, and please check our poster at the conference. Thank you.